Previously on Chalk Talk. Yeah, you know what that means, don't you? It means you're listening to part 2 of our 3-part series on how you can do ASIC design cheaper and easier than before. But, hang on. You. In the back there. Yes, you. I don't remember seeing you in part 1. Don't you want to go watch that first? I mean, it's up to you and all, but I like to watch my shows in order. Go ahead, hit pause. We'll wait. Okay, is he gone? Cool. Don't want any spoilers now, do we? Last time we talked about how you can save up to 75% on your ASIC design, which was awesome and all that, but I think we should turn this bad boy up to 11. Now, don't you? Hi, I'm Amelia Dalton, host of Chalk Talk. This time, we're going to talk about how you can potentially save up to 99% on your next ASIC design. My guest again is Reid Wender of Triad Semiconductor. And let's get started. I'm here to save that 99%. And remember, before we get started, go ahead and click that More Information link below your player. There you can register for a special ViaDesigner discount. Welcome, Reid. Thank you so much for joining me again.
Amelia, thanks for having me back. I've been looking forward to talking with you about Triad's technology.
Okay, so let's quickly review what we've discussed in the previous Chalk Talk. Tell us about Triad's configurable arrays.
Well, last episode we talked about VIA configurable arrays as a way to quickly and inexpensively make custom configurable analog and mixed signal devices. Here on this slide, we're showing one of our VIA configurable arrays called Mocha 1. It combines a Cortex M0 processor, RAM, non-volatile memory, 75,000 ASIC gates of configurable logic, and then we couple that with our patented VIA configurable analog resources, op amps, DACs, A to D converters, PLLs, etc. Basically, a VCA is a way to make a custom VIA ASIC without the expense normally associated with full custom design.
So the driving factor here is cost savings, right? And specifically design cost savings. Is that true? Increasing NREs have prevented a lot of engineering teams from considering ASICs, right?
Absolutely. For many people, ASICs are just too expensive, and that's why Triad got into the VIA ASIC business in providing our technology. A full custom mixed signal ASIC design can easily cost $1 million or more.
Phew.
And that's for somebody who really has been doing ASIC design, and for companies that are spreading out that cost across several designs. If it's the first time through for someone, it's just too expensive anymore to do a custom ASIC.
Right.
With Triad's VIA ASIC technology, we've been reducing the cost of configurable ASIC development by 75% and more.
Wow. Okay.
Yep, that is a pretty big deal for most of our customers. If you're considering an ASIC a full custom design, we can easily take that cost from $1 million down to $250,000. And the cost savings are in the upfront concept, the design, simulation and verification. Our layout costs are significantly lower, production test is radically reduced, and mass set costs can be as much as 30% less than a full custom design.
All right, Reid. Wow, this is great. But I don't think I'm going to find $250K in the sofa cushions. Maybe I could wash dishes or something?
Well, that's really what I wanted to talk with you about today. If you take a look at what makes up the cost of this $250,000 NRE, most of it's labor.
Ah.
I really am going to be asking you to wash some dishes.
Okay, fine.
No, seriously. If you were able to do most of the VIA ASIC development yourself, we can reduce the cost of developing your own custom configurable mixed signal device from $1 million down to less than $10,000.
Seriously?
Absolutely. We recognize that there's many companies in the industrial, medical, aerospace, defense markets where they would love to have the capabilities and the value of mixed signal ASIC integration, but they can't afford the high NREs. With the VIA ASIC approach and you doing most of the design work yourself, we can get that cost below $10,000.
Okay, Reid, so you've said I can save this money by doing the work myself, but I've always been a bit tentative on this whole some assembly required business. I'm a system designer, and I'm not so sure about building a mixed signal custom IC all by myself.
Yes.
I've worked with some of those mixed signal guys at my last job, and it wasn't just their beards that scared me. How are you going to help me? Help me bridge from systems to custom IC.
That's really the focus of what I wanted to talk with you about today. Via ASICs help you reduce costs from $1 million down to $250,000. For you to be able to do the design yourself as a systems designer, we want to show you ViaDesigner. It's mixed signal chip design software for everyone.
Wait, Reid, everyone, even my mama?
Well, by everyone, we don't mean maybe that broadly everyone.
Okay.
But by everyone, we sure do mean everyone that knows how to design circuits. If you're a systems designer, if you know how to design op amps and data converters using off-the-shelf parts from suppliers, we want to make it so that you can design custom via configurable arrays using our ViaDesigner software. ViaDesigner is a complete design environment for systems engineers. It combines schematic capture, HDL design entry in the form of Verilog and VHDL, powerful modeling environment including SPICE and VHDL AMS, and you can combine in one simulation SPICE, VHDL AMS, Verilog, and VHDL designs.
Very cool.
It also comes with what really makes this useful for a systems engineer: a powerful yet easy to use set of design wizards for creating analog and mixed signal circuits.
So, Reid, these are intelligent configurable IP blocks, right?
Exactly. That's another way to look at what this is. Create IP or function blocks or design wizards that allow systems engineers to create useful and sophisticated analog and digital resources without having to be an IC designer.
I see. Okay.
Couple that with the analysis tools in ViaDesigner. You can do simulations, estimate area, do power calculations, and simulate designs across process voltage and temperature corners. It's a complete mixed signal design environment for a systems engineer to develop their own Via ASICs.
Okay, Reid, walk us through the flow.
Taking a look here at ViaDesigner's flow, it includes design capture in a variety of formats, both schematics and HDL entry, simulation that includes digital, mixed signal, and analog, and what-if analysis for areas, Monte Carlo simulations, and process voltage and temperature variations. That's coupled in with these Via Wizard models, which model the IP that's available in a Via ASIC. And with a Via Wizard, you can create sophisticated functions inside the ViaDesigner schematic environment. What comes out of ViaDesigner is an executable specification. You can have a complete verification test bench, and it's your system architecture.
Okay, so Reid, just a second. I'm used to analog design and schematics. You aren't going to make me learn a whole new way to design, are you?
No, we recognize that mixed signal includes analog designers, digital designers, and even software designers. So ViaDesigner allows you to design in the environment that you're most comfortable with.
Phew.
For schematic capture, for an analog designer, you pull in symbols from our symbol library that can be configured using the wizards, but you don't have to worry about learning some other kind of modeling to use via ASIC. Analog designers can draw schematics for both analog and digital circuits.
Good. Okay, Reid, I've seen a lot of new schematic capture and simulation environments popping up on the internet these days, but not all of them I would consider using for real work, if you know what I mean.
I know exactly what you mean. I've played with some of those myself. But when you get beyond playing and you're looking at doing real work, ViaDesigner are built on Mentor graphics tools, which are the same kind of resources you would use for IC design or sophisticated schematic capture. They include hierarchical browsing, the support for multiple views. You can switch back and forth between schematic views and HDL views. You can do automatic symbol generation, and it's got a lot of template capability for generating resources the way you're used to doing in a schematic capture package.
That's great. So the last time I checked, mixed signal was a lot more than just analog.
Exactly. The best mixed signal designs are a combination of elegant analog features and digital processing. That's real world applications.
Sure.
So if you want to do the digital design, we don't constrain you to just doing schematic capture for digital functions. Instead, you can go right into the syntax aware HDL editor, and you can enter in Verilog or VHDL state machines or circuits to represent your design, and merge those together in a single environment and simulate both your analog and digital functions together.
Okay, Reid, you've given me a bunch of stuff to work with here, but I'm not exactly an expert at analog IC design.
And we don't expect you to be. ViaDesigner is a mixed signal design environment for systems engineers.
Ah, okay.
You're used to looking up data sheets and selecting components based off of performance parameters. So what we want to give you is a simplified way to create these sophisticated blocks. And we call that process wizards.
Okay.
Think of it as configurable IP or function generators, but a wizard allows you to instantiate, say for example, an integrator function. You then go into a form where you fill out performance parameters associated with that particular block, and then the wizard goes to the trouble of generating a VHDL AMS model and the underlying circuitry to represent that function.
Ah, okay.
What you get out of the wizard is a complete functional block including models and implementation that you can then instantiate in your design as if it was a symbol that came directly out of a product catalog.
Fantastic. I think I have the general concept down here. Can you give us a couple more concrete examples on how this works?
Sure. Digital to analog conversion is something that's needed in a lot of designs. You've got a digital circuit and you need to create an analog waveform for that. So we have a DAC Wizard.
Great, okay.
You pull up the DAC Wizard and you go through the configuration options and you can say, do I want a voltage output DAC or a current steering output DAC? Is it asynchronous or clocked? And then you pick the resolution from 8 to 12 bits, and ViaDesigner goes off and generates the DAC for you.
Very cool. Okay, I got that. What else do you have?
Well, how about an amplifier?
Sure.
You know, if you go out and looked at standard product parts, there's tens of thousands of amplifiers on the market.
Absolutely, yes.
We have wizards that allow you to create amplifiers with lots of different performance parameters. Do you want an operational amplifier? Is it single-ended? Maybe you need fully differential. Maybe it's a transimpedance amplifier or a transconductance amplifier, or just the OTA type of structure. Could be general purpose, low power, and once we get into low power, there's never low enough. So we have micro power, and we'll have nano power, and we'll keep going on with more and more options out of these wizards. Is it precision low offset, high speed? We may never be done with generating amplifier wizards, but already there's a large spectrum of performance capabilities you can get out of the amplifier wizard we have today.
Very cool. Okay, I think I'm starting to get how these wizards work. Do you have anything that's a little more complicated, sophisticated maybe?
Oh, absolutely. Let's take a look at the filter wizard. A filter, if you were going to go and design that by hand, could contain several op amps, resistors, capacitors, and switches. What you do in the filter wizard, you instantiate a filter component, then you go into the wizard form and you select, is it a continuous time filter or discrete time? It could be a switch capacitor filter or a continuous time filter. What's the filter type? Low pass, high pass, band pass, etc. Pick the corner frequency, the filter order, and the approximation. Do you need Butterworth or Bessel, etc.? And then you don't even have to leave the wizard to see what's the general frequency response going to look like. You click on the plot the transfer function, and you get a quick look-see at the kind of performance you would get out of that particular filter.
These are some great examples, Reid, and this seems like it would take a pretty big catalog. How many wizards do you have?
We released ViaDesigner in the second quarter of 2012 with the list of wizards or IP blocks shown here on the left-hand side. It included basic functions like resistors and capacitors. And I might just stop there for a second. Someone would think, do I really need a wizard to generate a capacitor? Well, inside a chip you do. A capacitor is kind of an elegant structure that if you don't know full custom IC design, you might not necessarily know how to put one together.
That's true.
But with the capacitor wizard, that's done for you. You pick the capacitance you're looking for, and it generates that. Analog switches, analog logic, op-amps, comparators, integrators, filters, ADCs, modulators, DACs, configurable I/O pads, band gaps for generating voltage references, power on resets. Those are all the functions that came out in ViaDesigner when it was originally released.
Okay, so what's the schedule look like for this roadmap?
As soon as we got ViaDesigner out on the marketplace, sure enough, people said, these are great wizards, but I need more. That's how we decided what would be the next wizards that would come out. We released a set of wizards in November of 2012 that included high voltage capability, regulators in the form of LDOs and linear regulators, clock generation, extensions to the analog to digital converter. In fact, initially when we came out with a sigma delta modulator, it was just the analog functions of the sigma delta modulator. Customers said, well, I'd also like to include the digital filter so I could turn it into a complete A to D converter. In the new release, we've added functions like sample and hold, programmable gain amplifiers, current to voltage converters, and we had requests from customers to add additional capability into the simulator.
All right, Reid, you're telling me that I'm going to simulate all this business. If I start a SPICE simulation, I'm going to have grandkids before it's done.
That's typically been the problem in an analog design environment. It's based on low-level SPICE transistor modeling and simulation. If you were to build a useful system, say maybe op-amps and muxes and filters and an A to D converter, it really can take almost forever for those simulations to complete. And we actually hear engineers complain the simulation won't complete before a core dump.
Wow.
Designers just don't do system-level analog SPICE simulation. In ViaDesigner, we use VHDL AMS models to represent the analog and mixed signal functions. The power of VHDL AMS means that simulations can run much faster, not 2 or 3 times faster, but hundreds or thousands of times faster than an equivalent SPICE simulation.
Wow, okay.
So that means when you make a system that's got data converters and digital logic and op-amps, you can run a complete chip-wide simulation and literally have that done in minutes. Now, inside ViaDesigner, we still have SPICE-level simulation. So when you need to dive down, you can selectively, inside any level of the hierarchy or on a block-by-block basis, go in and turn on precision simulation models or go up to the faster, more ideal models so that you can focus in on critical parts of the design without slowing the whole simulation down. So it gives you system-level simulation inside a mixed signal design environment.
Ah, I see. Okay, so how do we see our results?
Well, just like any good analog design environment, we give you a wonderful waveform viewer and analysis setup. The waveform viewer allows you to bring any of the signals in from any part of the hierarchy and look at them in both the time and frequency domains.
So, Reid, I can bring agile methodologies or test-driven design to analog? Is that even legal?
Maybe not if you were doing analog design last century.
Ah, I see.
Now, you don't have to. But if you want to, ViaDesigner supports full VHDL AMS modeling. That means you could start your design out with a model of the system without any schematics or anything representing the design in VHDL AMS. As you go to lower levels of refinement, you can represent the design with ViaDesigner wizards, and you can compare the results between the two.
That's very cool. Okay.
So if you're interested in test-driven design, we've got waveform calculators and measurement tools. You can save and compare results. You can build test benches that are self-checking, which for a mixed signal design is a wonderful way to prove that you have created a chip that satisfies your specifications.
All right, Reid, I'm sold. I'm ready to get started. Where do I need to go? What tools am I going to need?
If you'll visit ViaDesigner.com, you can register and download ViaDesigner and get started today.
All right. And what can I do with it? Do I instantly need to know the whole flow?
No. In 2013, ViaDesigner is a high-level VIA ASIC modeling and simulation environment.
Okay.
You don't have to know the back-end flow to do a VIA ASIC with Triad in 2013.
All right, that's a relief, so I don't have to learn how to run before I even know how to walk, right?
Exactly. You do the front end, and Triad will do the back end, and it will reduce your NRE of a VIA ASIC development as much as 25% or more, but it won't get you all the way down to the 10K that we talked about earlier.
All right, so that makes sense. I'm doing some of the work now, and so I can save some of that 250K NRE in the future, right?
Absolutely. In 2014, we'll be releasing more of the ViaDesigner flow so that you'll do both the front end and the back end of the design, and that's how we'll get you down to the lowest NRE possible.
Okay. I'm marking my calendar, and I'm going to be an experienced mixed signal IC designer, and my NRE is going to be 10K. All right.
Amelia, let's walk through turning you into a Via ASIC designer with
Let's
ViaDesigner.
do that.
In 2013, go to ViaDesigner.com. Register, download ViaDesigner, and start designing and simulating till your heart's content.
Sounds great.
But you'll probably have questions. Our vision for ViaDesigner.com is to be a global community of mixed signal Via ASIC designers.
Very cool. Okay.
Ask your questions about different IP blocks. How do I design this? How do I design a regulator? What if I want to send a voltage or a current to a particular area? What's a good circuit design approach? It's a community where you can ask questions and get answers. And you have the ability to upload your designs to ViaDesigner.com, browse and search IP from other designers, and download their IP blocks as starting points for your own designs.
Very cool.
Share the designs with others. In fact, you can form teams on ViaDesigner.com. Maybe you're an analog designer and you know a digital designer over in, I don't know, Singapore, and a software guy in Poland. The three of you together can create a really cool mixed signal design and share the rest of that IP with the community. The community then can add to it and help you make something truly useful. And in 2013, we'll also be having ViaDesigner contests. There'll be monthly contests where we'll put out a design idea, and you will go off and submit your best solution for that design problem. At the end of the month, the winner will get prizes, cash prizes that is, and recognition amongst the ViaDesigner community.
All right, Reid, that's fantastic. What are some of these contests going to look like?
Well, one of our first contests, and I guess I'm letting the cat out of the bag here, is to design the ViaDesigner.com theme song inside ViaDesigner.
Oh, cool. Okay.
Using only ViaDesigner Wizard, you have to build an analog synthesizer, save the waveforms, and upload them to ViaDesigner.com. The community will listen to them and vote on what they want to be the ViaDesigner.com theme song.
I love that. I'm going to enter myself.
I'm looking forward to hearing that one. And now, where it gets really exciting, here's a community of designers developing IP and reference designs inside ViaDesigner and sharing that information with each other. In 2014, the community will decide on the types of IP blocks they would like in their own custom Via ASIC, and the community will tape out Via ASICs and receive back Via ASIC designs that will be shared within the ViaDesigner community.
That's great. All right, Reid, let's circle back and let us know what we need to do to get started.
Pretty simple. Go to ViaDesigner.com.
Okay.
Get ViaDesigner.
All right.
Make Via ASICs.
Sounds good to me. And we've provided links for all of those below the player. Hey, Reid, if you wouldn't mind, you could hang out a little bit, show me how to do a design with ViaDesigner. I'm just saying it might be convenient since you're here and all.
Yeah, that's a really good idea, and it sounds like an episode 3 to me, Amelia. We'll do that.
And before we go, don't forget to visit those links below your player. There you can register for a ViaDesigner discount and visit part 1 of this Chalk Talk series. For Chalk Talk, I'm Amelia Dalton. For more Chalk Talks, check out the on-demand section of eejournal.com.